Astronomers for Planet Earth is an organization of professional astronomers and educators dedicated to helping people understand the causes, consequences, and solutions for climate change. This webinar series brings in experts to share their work to help you, the listener, be better informed and able to make a difference. Our host is Dr. Travis Rector, an astrophysicist at the University of Alaska Anchorage. Today's guest is Dr. Sarah Bridle, a professor of astrophysics at the University of Manchester. Sarah has diversified from cosmology into agriculture and food research, motivated by the need to reduce global greenhouse gas emissions. In 2017, Sarah founded the Science and Technology Facilities Council Food Network, bringing together food research and industry with STFC capabilities from astro, particle, and nuclear physics, and the UK's largest science facilities. Sarah leads the Take a Bite Out of Climate Change project and the Greenhouse Gas and Dietary Choices open source toolkit, which brings together data from food choices and greenhouse gas emissions to inform the public and policymakers. Sarah's book, Food and Climate Change Without the Hot Air, was published in 2020 by UIT Cambridge and is available as a free ebook. Sarah is author of over 100 refereed publications which have over 9,000 citations and has won prestigious awards in the UK and Europe, including a Royal Society University Research Fellowship, the Royal Astronomical Society's Fowler Award, and the European Research Council Starting and Consolidator grants.
Hi everyone, my name is Travis Rector and I'm a professor of physics and astronomy at the University of Alaska Anchorage. And I'm also one of the organizers for a group called Astronomers for Planet Earth. And one of our goals is to help astronomers be better educated about the causes, consequences, and solutions for climate change. And today our speaker is Dr. Sarah Bridle from the University of Manchester, who works in cosmology and, amazingly enough, also food science. And I'm especially excited to have her speaking with us today because when it comes to talking about climate change, food science is incredibly important, and yet it doesn't seem to get the attention it deserves. So thank you, Sarah, for joining us today.
Well, thank you so much for having me, and really fantastic that this is all happening and this group exists and it is so active. So so this is the kind of picture that I'm more comfortable starting a talk with for most of the last 20 years, looking at gravitational lensing and dark matter. I don't need to explain that slide to you, I expect. But I guess this story started when I was about 16 years old and I was trying to decide where to go to university. And I was very lucky, a mentor, a friend of my dad's happened to be a professor, well, he was working at Cambridge University and took us around punting and showed me how to derive the equipotential surface of the Earth's tides due to the moon, and I was just like totally hooked. I just had to do that. So I was determined to go and study physics and then astrophysics after that. I guess you're all familiar with these wonderful, this is me a long time ago, playing with Eli Rykhoff's fabulous GravLens 3 code, which allows you to lens your friends and enemies. So lots of fun. And I won't bore you with all of the cosmology story, but for me, this all came together about 5 years ago when a lot of the projects that we've been doing over the previous 10 or so years produced their first results from the Dark Energy Survey for cosmology. So that was a really exciting time. But at the same time, I guess I was trying to think, well, what to do next? And about the same time, I bumped into my old, my dad's friend from Cambridge, as he'd been mentoring me for a long time then. And it turned out he had terminal stomach cancer. And I guess that really sort of pulled me out of my kind of like not knowing what to do next and just made me realize, wow, I've got to do something with the fact that I'm here. And he'd actually had a really surprising career, first of all, as a world-leading computer scientist, but then he'd actually then gone on to sort of get concerned about climate change, very concerned about climate change, wrote a book about sustainable energy without the hot air, which I really recommend. It's aimed at politicians primarily, but lots of back of envelope calculations about how different things use up energy and how we can get clean energy and how those sums add up. So I was very much inspired by him and in awe of what he'd done, and just really wanting to do something that I could to try to help. And so I read a lot of his old slides and presentations and so on. And I saw that he'd identified food as being this really area with a lot of potential to help with climate change. And about the same time my kids started school, and I pictured them sort of saying to me in 20 years' time, "What did you do about climate change, Mummy?" And me saying, "I looked at the stars," and I kind of thought I've got to do something more than that as well. So started looking at our own planet and trying to find out more about climate change. I came across this fantastic visualization you might already know, Climate Stripes by Ed Hawkins, and you can download, this is basically showing the average temperature every year since 1850. And so the question is it bluer on one side and redder on the other, or not? And you can get a bag, you can get a tie, you can get leggings, you can get earrings. I don't know. You get all sorts of merchandise with this pattern printed on if you're into that sort of thing. But where is climate change coming from? Well, what I learned was that about a quarter of climate change is caused by food, and that includes clearing land for agriculture, also fertilizer use, animals, rearing animals, and processing, packaging, transport, and consumers at home cooking. And all of these things add up to about a quarter of all climate change. And then that's increasing because there's more people, and people are eating more greenhouse gas emissions intensive foods, generally more meat, but also hopefully we're going to massively cut down fossil fuels, which means that this green segment is going to go right down, and then food will be the biggest contributor to climate change, because most of the reasons why food contributes to climate change are not to do with fossil fuels. So there's more detail if you're into lots of details, which I'm sure you all are. You can see all the details on this slide here, and you can see that food causes about a quarter of all climate change, but that gets broken down into the industry and processing and buildings, but also crops and livestock, cutting down forests generally for agriculture. And this is generally nitrous oxide and methane. And also some of the land clearance from agriculture also contributes carbon dioxide, but it's not generally much to do with fossil fuels. At least, yeah, so there's still this big thing that's going to be there. And so in 10 years' time, I hope we're going to cut back on fossil fuels, and then food will be the biggest cause of climate change. But on the other hand, if we don't manage to cut back on fossil fuels, then we're going to have our food is going to be impacted by climate change. And so actually there's looks like a lot of the issues to do with climate change are going to impact on food yield from crops, but also from extreme weather events that could actually knock out a number of different food production places all at the same time, which would then have a massive impact on our society. If I know that you're super geeky like me, so you'll love staring at this kind of picture for even longer. I've put the link in, and I'll make sure you've got the slides if you're interested. But you can even see rice paddies on here, manure, burps, that means enteric fermentation, that's burping by cows. You can, pretty much every question, there's a line on here for it somewhere. So we're happy to discuss that more if you're interested. Okay, so a quarter of all climate change coming from food. Well, how can we make that more personal? How can we think about what that looks like? Well, if we divide that across all the people on the planet and assume we're all eating an average amount of types of food, then you can see here that the global average food emissions per person per day is about 6 kilograms. And we can compare that, for example, to driving a car 12 miles to a place and then back again, so 40 kilometers total. That's about the same. And 6 kilograms, let's try to make that more realistic. So could you lift 6 kilograms? I can lift 6 kilograms, but I wouldn't be wanting to hold on to it for very long. So it's a significant weight from just our food that we're eating. But also we could think about that in terms of balloons of carbon dioxide, if you prefer. So that's about 200 but party balloons of carbon dioxide going up into the air every day due to the food that we're eating. So how does that compare with flying? This was definitely very much on my mind as I started to learn about climate change after flying around the world a huge amount with collaborations in astronomy projects. So supposing that we make one transatlantic flight a year, which is definitely not as low as what I was doing when I came to realise all this, but one transatlantic flight per year, if we divide the emissions from that out across all the days of a year, then we end up with something which is bigger than the food emissions. So if we are taking one transatlantic flight or more per year, then that's the thing to really focus on, rather than obsessing about exactly what we're eating every day, probably. Hopefully we can all feel very smug at this point because of COVID having disrupted our travel plans, and we're all feeling very virtuous at the moment, probably anyway. Now, what should we be aiming for? Well, the Kyoto Agreement and Paris, they're talking about halving emissions by 2030. So supposing that we think about that as our goal for food for now, how could we halve our emissions from food, and what would that look like? So that would mean our sort of target is about 3 kilograms of carbon dioxide equivalent emissions per day. So let's compare that with some things that we might eat. So supposing we had an 8-ounce steak and fries, and how do you think that would compare with having a microwaved potato and beans? I mean, I'm not gonna, there's no prizes for guessing which one causes more climate change, but how different do you think those things are? And research shows that actually people generally greatly underestimate the size of the differences between different types of food. And that's really good news, because actually if all types of food caused about the same climate change, we'd be stuck. And so that's why this has got a lot of potential. Originally, when I started getting into this, I thought, oh, I'm going to look into crop yield. And so I used the same piece of code at one point to analyze a galaxy image, and also to look at a field with wheat in it, to try to look, because we have basically multiple wave bands. You've got an area that you're trying to look at and identify features like weeds in that field with different spectral energy distributions, for example. But actually, we can maybe improve crop yield by 10, 20, maybe 30%. But there's a limit to how much we can do. Whereas looking at the differences between different foods, there's such a big difference that this is why I ended up really focusing on this topic. And so this is actually about more than 20 times greater climate emissions, climate change from eating an 8-ounce steak and fries compared to a microwave potato and beans. And that includes the cooking of the beans and the potato, and also the steak and fries, but that's less of an issue in comparison. So you can see that already with the steak and fries, we've blown our daily budget, and we've not even had any other food for that day. Whereas if we had the microwave potato and beans, we're allowed to have a few more things on that day, which is good news. Okay, so how about this? So what do you think causes the most climate change out of a bowl of cereal, a large latte, or 2 boiled eggs? And I wonder what fraction of that daily target you think we're going to use up from each of those things. So hopefully you'll pause the video now and have a little wonder about that, and check back in when you've made. Some people, I did a seminar yesterday actually at Duke 2 days ago at Duke University, and they started suggesting ratios, which was getting very geeky. So you can even have a guess as the ratio of greenhouse gas emissions between each of these food options. Okay, so I'm going to reveal the results now. So what you can see here is that it all comes down to lots of things about the amount of milk, which I didn't specify, but I did use typical values of about 200 millilitres of milk for the bowl of cereal, or 500 millilitres of milk for a large latte. And you can see that really it's the amount of milk that's important in those two cases. For the boiled eggs, we've got mostly it's the eggs themselves, not the boiling, that causes the climate impact. But at the same time, so the eggs, it's really about what the chickens are being fed. That's the main contributor to climate change. So if that generally includes a proportion of soy, which in terms of global average may come from regions which have been deforested, which also contributes to that. But you can see all of these leave a bit of room for some other food, maybe not so much with the latte, but the other two, we've got some more space for other food options in the rest of the day. Okay, so supposing we go to lunch, maybe we're thinking about a ham sandwich, a lettuce salad, or a pot of yogurt. So have a pause and think, what do you think causes the most climate change out of those three options? And if you want to go crazy, you can even try and guess what the ratios are. Okay, so I'm going to reveal the answer. So for this particular selection of 50 grams of ham, and using global average values for pork meat, you can see there that the ham sandwich is causing more emissions than the other two options, and that's mostly because of producing food for pigs, but also from the manure management, the way that's treated, and whether that decomposes into methane if it's kept in a place where it can't get access to enough oxygen to decompose into carbon dioxide. Okay, but we've still got room for other meals, which is good news. So let's move on to another. What about snacks? So which of these snacks do you think causes the most climate change? So we've got a bar of chocolate, just 25 grams, a regular, I guess, UK size packet of crisps, which is about 25 grams. I know they're a little larger in the US, but we've also got a banana there, which has come from the other side of the world, or an apple, which has been trucked across a small country like the UK. So maybe have a pause and try to guess what you think is the most climate impact out of those options, and how do you think it compares with this target of 3,000 grams per day. Okay, I'm going to reveal the answer. Okay, so for this 25-gram bar of chocolate, then we've got the processing of the chocolate, the milk, and the cocoa all contribute very similar amounts. Now, the values for cocoa are actually very uncertain because it depends a lot on what the land was used for before they started growing cocoa trees. So this is cacao trees. So these are trees which are sequestering carbon in their roots and in the soil and in their trunks. But on the other hand, if that was planted on a deforested region, then they're not sequestering as much carbon as the forest was. On the other hand, if it was previously agricultural land used for growing annual crops, then it would actually sequester more carbon than that. So this is a very much an average value that I've shown here. Interestingly, you can actually fit more than 25 grams of milk in a 25-gram bar of chocolate because it's using powdered milk. So the milk does contribute a bit there, even though it's a very small weight of milk powder. What you can also see is that the transport of the banana is really not a big deal. And that point was very much made by Mike Berners-Lee in his fantastic book, How Bad Are Bananas? Which is really not that bad, as a spoiler alert there. So this is just because shipping is not nearly as bad as a lot of people might guess. In fact, shipping things, if you ship the same weight of food by boat, or if you bring that by air, then bringing by air contributes 100 times as much climate change as bringing by boat. So it really depends on how these things are transported rather than so much the distance they're transported, because you can see there that it's kind of comparable to just producing the banana in the first place. And compared to this target of 3,000 per day, then it's really not a big deal. Great. Okay. And finally, which out of these three options do you think is going to cause the most climate change? So chicken curry and rice, apple pie and a small amount of cream. I think it's custard in this picture, but I'm using cream in the calculation, and a bottle of beer. And a lot of people get very anxious at this point that they're going to have their bottle of beer spoiled by this information. So have a guess. Okay, so I'll now reveal some answers there. So yeah, so the chicken tikka masala and rice is actually more contributing to climate change than the bottle of beer. So a lot of people are very happy to hear that. But comparing that to something like the apple pie and cream, you can see there that actually putting the oven on, even if you're sharing that emissions out between 4 people, that's actually one of the biggest contributors to that. And then the butter after that in the pastry. The actual apple itself is not a big deal. In terms of the chicken tikka masala and rice, and you can see the rice is not actually negligible because rice is grown in paddy fields, which are generally underwater, and there's actually methane produced when things decompose without access to oxygen. So, for example, under the layer of water, and so that's contributing to climate change too. And also, there's dairy products in that chicken curry sauce as well. Okay. And we could actually look at different options here. So this is looking at how we might change a particular meal. So for example, a spaghetti bolognese with beef versus with chicken or with lentils. And even with a tin of lentils, a can of lentils in this spaghetti bolognese, it's still roughly halving emissions compared to a chicken spaghetti bolognese, or what's that, a factor of 7 almost for the comparing with the beef spaghetti bolognese. So what I normally say to people is that, maybe look at quantities first, and look at maybe just halving the amount of beef in that spaghetti bolognese would make a big difference and might not necessarily affect the flavour so much. So that would be my general advice, would be to look at quantities. But it's kind of depressing thinking about reducing quantities. So maybe think about it as bulking up on adding lots of vegetables, or maybe a tin of kind of pulses to that. And inevitably you'll end up with less meat in your portion and have a few portions to put away in the freezer as well. Okay. Oh, and looking at different options for the curry then. So comparing with, like, my favorite, I love lamb curry. It's really bad news. It's really gutting saying this here. So chickpea tikka masala, or I think they're called garbanzo beans in the US. So this is, you can make a reduction there by switching out the chicken for the garbanzo beans, and that gets you within, you can fit some other meals into the day on eating that one. Great. Okay, so what can we do about this? Well, being a data geek, as I'm sure you all are, I want to see these numbers. So all the numbers I've been showing you so far are from the academic literature, where people have studied these systems and written research papers on them. But actually, if you go to the supermarket, what you find on the shelf is going to be some other number, which is going to depend very much on how that food was produced. And so I really want to see labels on all of these foods, and this fantastic article here by Joseph Poore, who's one of the leaders in this field and who wrote the main compilation paper that everybody uses. Just saying, we already do this for some products, why not for food? Well, I mean, it is a bit more complicated because you could check the energy rating of a fridge just by putting an energy meter into the wall and looking at its efficiency, but it's much harder to sort of check and to sort of monitor and assess the accuracy of these numbers for food. But at the same time, we really need to start doing this, because otherwise we've got the climate impacts of foods and we're kind of blundering about in the dark, disagreeing on what we do about things if we don't actually have the numbers to have a calmer conversation about it. This was actually done about 10 years ago. This was done on Walker's crisps, which is translates as chips in the US. They actually put on their packets 75 grams of carbon dioxide per packet of chips. I have to confess, if I'd noticed that number 10 years ago on my packet, I would not have had a clue what to do with that number. Is it a high number? Is it a low number? I would not have had a clue. So in a way, we kind of need, it's a bit chicken and egg, if you excuse the food analogy, that we kind of need to have a hunger for these numbers at the same time as them starting to come. And so that's partly why I'm so keen on talking about numbers, even if they're approximate, because it means we've got a framework to put these more accurate numbers into. And there's other products that have started to do this now more recently. So there's a Quorn Mycoprotein have started to put their numbers on their products, and this oat milk also started to do that. And I really think this is what we need to be doing. Flora Butter have started to do it. They're putting a number on their packets, which is in 0.5 kilograms of carbon dioxide per 100 grams of butter. Now, being a sort of data pedant, I'm sure you're all horrified by the fact that we've got different units on the top, and this could have been a dimensionless number, but they've gone and put kilograms. Anyway, it's good to have the numbers there, but we do need to make sure we're all using the same terminology. That would really help a lot. And this is also going out on some restaurant menus. And in Denmark, they've actually, the government has said that they are going to work with supermarkets to put these stickers on all foods with the carbon footprint, which would be an amazing outcome. And I'd love to see this kind of statement made in more countries. Okay, so what can you do about this? Well, I mean, I'm personally I think it's exciting and interesting to play with different food options individually, but I think that we need to also do a lot more than that in terms of talking to other people. And so we've been having fun going to science exhibitions and music festivals and so on, at least before COVID, this was talking about this topic with people. And this had a great time in London a year and a half ago, talking to the public, talking about the number of balloons that corresponded to a small, a 50-gram piece of steak there, 100 balloons. So you can also play this game. So this is online, accessible from our website. Anyone can play this for free, and it's sort of point and click, and it's a bit addictive. You have to guess which is the lowest greenhouse gas emissions and then the next lowest. Sometimes that can be a way of getting a conversation going with people who are into pointing and clicking, maybe more than sort of bringing up a serious topic and freaking them out about the seriousness of all of this. At the same time, maybe another option here is that we've made these flashcards. So we actually got packs of these cards, 72 different cards in there that you can download for free from the website. It's quite a lot of cutting up if you print it all out and cut it all up. But on the other hand, maybe the easiest way to get hold of them in different countries. So this is showing the greenhouse gas emissions there, but also the water footprint, the amount of fibre and calories and protein that you can get from those foods. So there's a lot of different games that you could do to look at. People often play top trumps, but we're also doing projects with kids where they have to sort of add up the protein that they get from their meal and then see if they can get the same amount from different combinations of foods, that kind of thing. And if you are a data geek, like I think you probably are, then you'll be happy to hear that there's a spreadsheet of all the numbers that go into those cards and all the original references of where those numbers come from that you can play with till your heart's content. There's also a lot of numbers in this, in my book, but just to point out, I'm not trying to make money out of you. There is a free ebook, thanks to funding from the University of Manchester, or it's available in the shops like regular books as well, of course. But this is the link to the free ebook if you're interested in having a look at some more of these charts. And there's also a calculator that we've put online, so you can select any of the things that are in the book, for example, or add your own things, and then change the quantities and see how that affects the greenhouse gas emissions. So this is the latte that we looked at earlier, and you can click to see a breakdown of all the different contributions to that, and see you can change the amount of milk and that kind of thing if you're interested. And then we were locked down, I guess, in sort of April when we were planning our summer of activities. So we all got together and did an online thing. These are all the fabulous people that worked with on this. We had a great time considering that we were all locked down. We decided to put out a new video every weekday in June. And so we interviewed experts, we had conversations about the great work the kids had sent in, and conversations with each other about these topics. So there's a whole load of resources there that are available if anybody's interested. So if you want to find out more, then you can go to our website. We have very, very infrequent updates, but when we've got a big new thing, we'll be letting you know about it each time. So look forward to hearing your questions, and thanks very much for listening.
Fantastic, Sarah. Thank you so much for sharing those slides. And I'll mention that I'll put the links to all of the different slides that Sarah mentioned today in the comments for this video so that you can go directly to them. Well, thank you so much, Sarah, for joining us today. It's been a pleasure listening to you, and I look forward to the Q&A session that we'll have. Thank you again.
Wonderful. Thank you so much.
We hope you've enjoyed today's talk. Each of our talks is followed with a Q&A session that you can learn more about in the video description. If you're interested in Astronomers for Planet Earth, you can learn more at our website, astronomersforplanet.earth, and on social media as well. If you would like to be notified about future talks and events, please follow and join us.